Good morning, students. Previous video session we have discussed the motion on a vertical circle, and I believe that you all practiced well because it is one of the important 5 mark questions from this unit. And today we are going to discuss a new topic, that is power. First, you have to know what is the meaning of power. You know this thing, in many places we use the word power. One good example I will tell you, in our house we are using the motor pump to pump the water from ground to our water tank. When we use the motor, when we are buying this motor pump, we have to use we are using and we are trying to get the highest horsepower pump. They will be saying, sir, this is 1 horsepower or 2 horsepower. So this horsepower we are using commercially in automobile and this type of field to tell this power. That's what 1 HP, 2 HP motor pump we are saying. If you are using the horsepower, high horsepower pump, fast you can fill your tank, so it will reduce your electric charge. That is one of the great application we are using in our home based on the power. So power means this is what, how much fast or how much slow we have complete our work. That's what I told. You are using 1 horsepower pump and nearby house they are using maybe some 5 horsepower pump. So their water tank will be filled within 2 minutes. Our water pump will fill, our water tank will fill. The tank maybe it will take more than half an hour because they are using high horsepower. Fast it will complete its work. We are using 1 horsepower, it will take some time to complete the work. So that is what, based on this, there is a definition for power. Power is rate of doing work. Power is the rate of doing work done or energy transferred. You can use this formula, P is equal to W by T. Rate of doing work done divided by time taken. The same you can use average power definition, the same only. What are? Average power is defined as the ratio of total work done divided by the time taken. So to complete the work, how much time taken? That is what the power. So power is equal to work done divided by time taken. That is the formula. Now this power unit is watt. Power unit is what? Watt. And power is a scalar quantity. Its dimensional formula is ml square p power minus 3. ml square p power minus 3. Based on this work done by time taken, we have found in the dimensional analysis topic. So ml square p power minus 3 is dimensional formula for power, and the power formula is work done by time taken. Power definition is what? Power is the rate of doing work done or energy delivered, and its unit is watt. Watt means Sir James Watt is the first person who have invented the steam engine. To complete the work is here. So in the honor of James Watt, the unit of power is given watt, or you can use joule per second. So 1 watt you can define. 1 watt you can define as what? 1 joule of work done in 1 second. In 1 second, 1 joule of work done. That is what 1 watt we are seeing. So we have learned the 3 definitions. First one is power. Power definition is what? Power is the rate of doing work done or energy delivered. Average power, what? It is the ratio of work done by time taken. And now you can define this 1 watt. 1 watt is what? 1 watt is defined as the 1 joule of work done or energy transferred per 1 second in 1 second. That is what. Now we are using many unit for power. Highest unit from watt. That is lowest unit. Then what? Normally we are using watt. Then for highest unit we are using megawatt. Then what? Gigawatt. First we are using kilowatt, megawatt, gigawatt. Kilowatt means what? 10 to the power 3 watt. Megawatt 10 to the power 6 watt. Gigawatt 10 to the power 9 watt. This is the value we are using for highest unit. Kilowatt, megawatt, gigawatt. Kilowatt means what? 10 to the power 3000. 1 kilowatt is equal to 1000 watt. 1 megawatt is equal to 10 to the power 6 watt. 1 gigawatt is equal to 10 to the power 9 watt. Now this is what the power. Now I said commercially in automobile field and engineering field they use horsepower. 1 HP horsepower which is equal to 746 watt. So 1 horsepower is equal to how many watt? 746 watt. This is commercial use. And in our house and all electrical energy we are using, getting our current bill, electricity bill every month. That is calculated based on this kilowatt hour. Kilowatt hour. So 1 kilowatt hour means what? 1 into 10 to the power kilowatt. 3 into in 1 hour 3600 second. This is how our electricity bill is calculated. You can see in your meter and all. You can go and check in your house. Outside meter it will be written kWh, kilowatt hour. So maybe you used what? Some 1 day you used 8 unit. So 8 into 10 to the power 3 into 3600, like that it will be calculated. So this is what the power calculation and all. So this is all about power. First power. Power means what? Means what? Just how much fast or slow you completed and work. Then formula. Power formula is work done by time taken. Average power definition is ratio of the work done by time taken. Then formula same only. Then what? 1 watt. How we can define 1 watt? Joule per second. Power is a scalar quantity. What quantity? Scalar quantity. And its dimensional formula is what? ml square t power minus 3. And the unit we are using is watt. In the honor of Sir James Watt, who invented the first steam engine. And then what? Highest unit. What the highest unit is what? Kilowatt, megawatt, gigawatt. Kilowatt means 10 to the power 3 watt. Megawatt means 10 to the power 6 watt. And gigawatt means what? 10 to the power 9 watt. And commercial use they use what? HP, horsepower. 1 horsepower is equal to 746 watt. And then electricity bill calculation we use kilowatt hour. So 1 into 10 to the power into what? 3600 second. That is what calculation. Next, you can see page number 190 on. It is given 4.3, 190 and 191. Definition of power, definition of average power, then instantaneous power, then unit of power, then 1 watt, how you can define 1 watt, and 1 HP is equal to 1. Then you can solve example 4.18, it is your homework. Based on this formula, you can calculate, practice this problem, and in fact, incandescent bulb we are using in our home, the filament bulb, it can glow 1000 hour. The same, the CFL lamp, chlorofluoro lamp, that is what we are using in our home previously. That CFL lamp, you can use one lamp for 6000 hours. At the same, if you are using LED, you can use it for 50,000 hours. That means 25 years you can use one LED bulb, but you have to use daily 5 hours. So if you are using 5 hours, the LED bulb, it will go around 25 years. That is what one advantage of this LED, and you will get a less electricity bill if you use this LED bulbs. Okay. Then there is a relation between power and velocity. Relation between power and velocity. This is one very, very important 3-mark derivation. You know the order formula. Between power and velocity. For that, first you take LHS side. This is LHS. This is what RHS side. So first you take LHS. W you can integrate. So dW. When we integrate W, dW we will get. Now you can multiply. Take this one. Multiply and divide by dt in equation 1. So W equal to dW into multiplied by dt divided by dt. So you can write this dW by dt into dt. Just we are rearranging and writing dW by dt into dt. Understand that? So first we are taking LHS, W we are taking, W integration is dW. Then from that, with that what? Just multiply and divided by dt. It is very simple and very, very important 3-mark question in this unit. So we got LHS. Now RHS is what? F dot dr. F dot dr. So here also you take equation 2, substitute now, multiply and divide by dt. Multiply and divided by dt in equation 2. So what we will get? F dot dr into dt multiplied divided. So rearrange and write up. So F dot dr by dt into dt. This is what RHS side. Now you know this. R means what? Dr means displacement, position vector. So displacement dr means displacement by time. Displacement by time is velocity. V is equal to dr by dt. So you can write this equation f dot dr by dt into dt. You can write what now? What you can write now? F dot v into dt. Now you take LHS equal to RHS. Now you take what up? LHS equal to RHS. So LHS is what up? This one. dw by dt into dt. dw by dt into dt. RHS is what up? F dot v into dt. Now take it one side up. So dw by dt into dt. Here plus when it comes this side minus f dot v into dt. Now here dt, there dt, take it commonly outside. So you can write this dw by dt minus f dot v into dt equal to 0. Okay. Now you know here 0. So dt when you are taking that side, what will come? 0 by dt is 0 only. So we will get dw by dt minus f dot v. Or you can write dw by dt equal to f dot v. This is the relation between what? Relation between what? Power and the velocity. It is one of the very important 3-mark question. So you see, first you can write the work done formula W equal to F dot dr. Then take LHS separately, RHS separately. LHS is what? W. So integrate dw, then multiply and divided by dt in this equation. So when you multiply and divide by dt, here we will get this equation. Now take the same right side multiply and divided by dt. So we will get what? Here dr by dt means displacement by time. So that is equal to velocity. So what we will get? F dot v. Now LHS equal to RHS you take and you can find this relation. This is what one important 3-mark question in this unit. Next is you can see page number 192. Page number 192, session 4.3.3, relation between power and velocity. It is very important 3-mark question. Next one is collisions. Collision means what? You know this collision, which is we are using this term in our daily life, and we used to play the game like carom board, billiards, and all these type of games. There will be collision between the coins and collision. In carom board playing, we are hitting one coin by using what? Another coin. So because of the collision, it is moving. We are applying force on one coin, and due to this another coin to move, it is due to water. It is water. There what is happening? Collisions. collisions happening. So during this collision, you see one mass is hitting on another mass, so there will be some velocity. So mass is acting on another mass, it is what causing velocity, mass into velocity, momentum. So during collisions, there will be what linear momentum. So always remember that during collision, before collision how much momentum applied, that will be equal to after collision. You are hitting a coin, so you are applying a momentum produced. How much momentum before collide with another coin, that will be equal to after collision. So the momentum before collision is equal to the total momentum before collision is equal to the total momentum after collision. Here not only momentum, here kinetic energy also there. It is moving. So this kinetic energy won't be same. Maybe you are giving more force, so the kinetic energy will be more. After hitting another coin, the kinetic energy vary. Maybe it will increase, maybe it will decrease. So the total kinetic energy before collision and the total kinetic energy after collision won't be same always. But the total momentum before collision always will be equal to total momentum after collision. So based on this, there are two types of collision: elastic collision, inelastic collision. Elastic collision and inelastic collision. Elastic collision, you can tell all these examples: billiard, carom board and all. So in these all, total kinetic energy is total kinetic energy before collision is equal to total kinetic energy after collision. So during collision, what will happen? Kinetic energy change. Based on this kinetic energy change, there will be two types of collision, but momentum won't be changed. So elastic collision means the total kinetic energy before collision will be equal to total kinetic energy after collision. Before how much kinetic energy, after also the same kinetic energy. Billiards is good example for that. Elastic collision. So total kinetic energy before collision is equal to total kinetic energy after collision. Total kinetic energy before collision is equal to total kinetic energy after collision. That is what? Elastic collision. And inelastic collision means total kinetic energy before collision not equal to total kinetic energy after collision. Not equal. Total kinetic energy before collision is not equal to total kinetic energy after collision. That is what inelastic collisions. So there are two types of collision here: elastic collision and inelastic collision. Elastic collision means what? Total kinetic energy before collision is equal to total kinetic energy after collision. But inelastic collision means total kinetic energy before collision is not equal to total kinetic energy after collision. And there are some few difference given in page number 194, table 4.4. Comparison between elastic and inelastic collision. You can see a table. It is one of the important 3-mark question. So first difference, elastic collision, inelastic collision. First comparison is what? Momentum. Total momentum is conserved. Here also same, total momentum is conserved. Momentum won't be changed before collision, after collision. Momentum is what? Same. Then total kinetic energy. First one, second one is what? Total kinetic energy is same. But here not equal. Total kinetic energy not equal. Total kinetic energy is conserved where? In elastic collision. Total kinetic energy is not conserved in inelastic collision. That is what the second comparison. Then third one is, you see, for best example, inelastic collision. Assume that you have a bubble gum or something. One vehicle is going. You are just throwing that bubble gum on that vehicle. So how much kinetic energy you thrown, that will be different once this bubble gum is pasted on that vehicle. Now, once the bubble gum is pasted on that vehicle, that bubble gum will move the same speed as the vehicle moves. That is what the kinetic energy is different. It is not conserved. That is in elastic collision. And the third one is force. Here conservative force. Here what are? Here non-conservative force because of frictional force. Here, you know, when we are playing the billiards and carom board, always we are using what? Frictionless. We are applying the powder on the board to reduce the friction. So for the softness, then only easily the coil will move. So forces are conservative force. But in inelastic collision, you are throwing the bubble gum on the vehicle. When it is pasting, there will be friction between the bubble gum and the vehicle. So what is happening? Energy is losing. That is what forces are not conservative forces. And the last difference is mechanical energy is not dissipated. Here forces, conservative force, not conservative. And last one, mechanical energy is not dissipated. Here light, heat, sound. Mechanical energy is not dissipated during elastic collision. Energy is not wasting. That is what? Energy is not losing during elastic collision. That is what dissipated means. And here in elastic collision, during inelastic collision, energy is water dissipated in the form of light, heat and sound. So these are the four differences. Comparison between elastic and inelastic collision. First one is water, momentum, both side it is conserved. And the second one is kinetic energy. Elastic collision kinetic energy is conserved. Inelastic collision kinetic energy not conserved. And third one is forces are conservative. Here forces are not conservative. And the last one is mechanical energy is dissipated during elastic collision. Here mechanical energy is here not dissipated, but here it is dissipated like water, light and heat and sound. Energy is wasting here. Elastic collision energy is not wasting. So my dear students, practice this all and learn this table 4.4 and relation between power and velocity from page number 192. This table 4.4 from page number 194. Learn it all, study this. It is important question. Thank you all. Bye bye.